Hello, thank you so much for giving us the opportunity to present to you today. We want to show you why our design for Universal Remedies Network will be the most secure, the most robust, the most efficient, and the best for the price point possible that you can afford and that you can utilize, and that will give you the best experience possible for your employees and your users. So let's dive into things. We want to start out with our addressing plan. And so there's a couple important points that we're going to get into here. When we're talking about our addressing plan, that's really talking about subnets and VLANs, because those two things are really important to network security. We'll talk more about that later on in the video. But subnets and VLANs help segment your network so that only specific users can have access to specific information. And as you can see here, this details how our subnets and VLANs correspond to each other. For example, our management VLAN is the first one you see there. That is numbered 10. And the subnet that corresponds to it very conveniently is 192.168.10.0/28. And all of our VLANs and subnets follow that pattern, where the VLAN number shows up in that third section of the IP address range. We did that intentionally so it's really readable. So if I'm looking at an IP address on the network, the overall network, I can know what subnet that's on for the network engineers who are implementing all of these things. And it just makes it, like I said, very readable, very easy to understand. All of these subnet ranges as well are subnetted for over 50% growth. We know that the company is making a lot of moves in the market. We know that the company is growing quickly, and so we know that it's important to have that built into the system. For example, that management subnet can facilitate up to 14 users in that office. At the moment, there's like 5 or 6 users in that office. This allows us to have more than double that. And it's also really easy for us to change that /28 subnet into /27/26, doubling the size of the users each time because of how we have it spread out on the network with the VLANs and the subnets only going to 192.168.10, 192.168.20, etc. There's a lot of room in between there that we could add to those VLANs and subnets, and so that allows us to have growth very easily. Then when we get to point-to-point connections, there's a certain number of those that's dependent on how many switches, our layer 3 switches and routers that we have on the network. That allows us to get from point A to point B. If I'm on one VLAN, I need to communicate with a computer on another VLAN on another network. They need to go out of the system, go to the internet. That's what these point-to-point connections facilitate. The way that they're designed is you only need to have 2 usable addresses per point-to-point connection, and so those are all /30 subnets. We have them all listed out here. They just move sequentially. So if you needed to have more point-to-point connections, you could easily add those in for the future, because we've only gotten so far, you can see, up to 54. That can go up to 255. Right, so we can have quite a few more point-to-point connections if we change the topology of the system with growth. And so just to kind of summarize what the key points of our subnet addressing, VLAN, all of that, the addressing plan, it utilizes the private subnet 192.168.0.0. That's a secure private subnet. That's something that we can very easily use and implement. Like I said, it allows us to manipulate the addresses so that it's readable. Like we said, with the VLANs and the subnets that correspond to each other, there's currently 18 VLANs on the system following that pattern. That means that we could have 7 more, because we can go up to 192.168.250. And so if we did that, that would allow us to add 7 more VLANs. If there were 7 different departments, 7 different rooms, there's a growth that way that we can facilitate. And if necessary, if there were even more growth than that, we could easily change how we count those VLANs and subnets and facilitate many more. All right, so jumping into our topology, you can see it's very extensive. We have 2 different buildings, right? We have the office building and the laboratory that we're accounting for. Those 2 buildings are connected via a VPN, which is represented by that red line. In the middle there, we'll kind of look at the buildings individually, but kind of like I was explaining with the different VLANs and subnets, every single department has its own VLAN and subnet. Some of them share physical networking devices because they share offices and office spaces, but because of those, the VLANs, the virtual segmentation that way, there's still security between those 2 offices, those 2 departments, even if they share equipment and space. And so, as you can see, all of the departments. We have it color coded on here. You can see the actual physical topology diagram that we'll deliver to you separately as well to examine these things more closely. But every room, every department has its own VLAN and its own subnet. And in addition to that, something that we really like to advertise to you is the fact that there's wireless access points throughout the building. So there's Wi-Fi that all of the employees in the company can use wherever they are in the building, that's still separate from the individual networks that are all wired. So each office has its own network, but there's an overall network employees can use for their different devices, for their phones, for their laptops that are still on the overall company network, just not on these specific VLANs. But then getting into the lab, it's a very similar thing. The main point about the lab is, like, we know the operations lab specifically needs to be air gapped. It's not going to access the internet. We don't need anybody on the internet to be able to try and find any of those IP addresses, try and get any of that information, since it's incredibly confidential. So that's air gapped. It still is able to interface with the other labs that are then able to interface with the network, with the internet, but because of how we have it configured, it's not going to be able to access the internet, even though it's going to access those labs because of how we have the VLANs set up. Those VLANs aren't going to be able to access the distribution switches or the access switches that are going to take us to our router and take us to the internet.
Great. The next part that I'll be presenting on is the bill of materials. So this is where we went in and actually took note of all of the materials that we would be using for this. And so just to give it to you as a large overview right here, you can see I categorized it as the networking hardware, connectivity and cabling, servers and storage, the types of labor that we would need, as well as any reoccurring expenses that would continue as the years go on. So we'll break it down a little bit here, but this is just a reminder that it's based off of this topology diagram. So any of the routers, switches, distro switches, and access switches, these were all recorded here and taken note of. And so yeah. Okay, so if we're looking specifically here at the networking hardware, these were all of the specs for which routers and switches that I chose to use, as well as for the wireless network. And this was based off a range of things. It's important to keep in mind how James mentioned earlier that the lab part of the network was air gap, so I wanted to make sure that I used switches as well as cables. I'll talk about those in a second. But things that worked well for an air gapped network. So that was something that we took into appliance here, as well as with the connectivity. The cables that we decided to use, keeping in mind the distance between buildings, and that they would need to be cables that could endure a little bit of wear and tear, considering that it's going through parking lots, through the walls, things like that. We wanted to make sure that the connection wasn't broken off due to a break in the cables. With the servers and storage, this I went through. These were similar to the ones, the servers that we used. I worked an internship this past summer up in Logan, and they were doing something similar to this actually, where they were moving into a new building and needed to set up some of the networking things there. So some of the servers that they use there on their network are similar to what I decided. It's a pretty similar size company as the one that we're working on here. So I was just able to apply those to this here. As far as labor goes, the two main people that we would be needing help from is the network engineer and the cabling technician. And these are estimates for about how long I thought we would be needing their help for, just to get everything set up together well, since they're professionals at that. And finally, with reoccurring expenses, this is things like the cloud. I decided to go with AWS for that. But we just needed to make sure that all of the types of subscriptions and things that we would need there were all accounted for. So if we go back and look here, the quantity of how many of each thing was taken into account, as well as the price of each one, and then finally a total cost for what that would look like, and the total expense, as well as the annual cost after that.
All right, so now we're going to go over the security document. And we created this document for you guys to ensure that the network stays safe. And so we go over a lot of different policies for you guys to implement, as well as some policies we took into account while configuring the network. So we're going to focus on, I'm going to focus on three main topics from this document: the physical security of the network, the actual network security, and then a couple other considerations that you guys should keep in mind. And hopefully you guys are aware, but there's a lot of malicious attackers out there, and they will attack you. It's just how the world works these days. Any network that exists will be attempted to get into, broken into by a hacker. So we really wanted to create robust security measures to ensure that that didn't happen, that the health data that we had wasn't compromised. So the first thing we had to secure was the hardware. These is like the actual computer, the actual cables, all of these things. Because if someone could tamper that, if they cut a cable, connection's gone. If they destroy a switch, that's bad. But also, if they plug into a switch and they reroute traffic, or they monitor everything that's happening, that's getting sent to that switch, then that's also bad, because they can see all the traffic that we're sending in this work network. And so we put most of the hardware in two main locations. It's either going to be in the wiring closets that are kind of spaced out around the buildings, or in the server room, with the only exception of the WOP, the wireless access point, that is on the ceiling, but it's high and out of reach. And we wanted to make sure that these weren't just available to everyone, so they're locked rooms. For the wiring closets, only the IT staff have keys. And then the server room, this is where we keep a lot of our backups as well, so we wanted to make sure that leadership had access to that. But we wanted to make it more secure as well, because that's pretty confidential, and so it's locked and biometric as well. Another factor we took into account with physical security is environmental factors. And so for power outages and surges, we made sure we bought UPS units and installed those, and also had surge protectors and backup generators. On top of that, with the dry climate and the temperature extremes that can happen in this area, we wanted to make sure that HVAC is upkept, and so that's something that we need to monitor and ensure that not the density, the moisture density.
Humidity.
Humidity, thank you. The humidity is constant so that our servers and computers don't break. With fire threats, we want to make sure that fire alarm systems are installed, that there's fireproof doors for all cabinets and server rooms, and also that we have fire suppression systems in labs, non-water based, so they don't destroy the equipment when they go off. Room location also, we wanted to make sure that these were not obvious rooms, so that it's not obvious if a hacker were to infiltrate physically where they should go. Okay, so the actual network security. We identified like the main entry points that someone could get into our network, and then we decided to harden those entry points and make sure that they were extra secure. So, getting in through the internet, we made sure that firewalls are installed. So firewalls block all of the traffic that are coming out, except for what we explicitly say is allowed to come in. Internal Wi-Fi, we made sure that only company managed devices will be allowed to connect to the internal Wi-Fi network. That'll ensure that no rogue devices get in. The guest Wi-Fi is another, could be sketchy network that somebody could gain access to, but we made sure to keep it fully isolated with a dedicated VLAN like we talked about earlier. And we also prohibit it from employees. They should be using the network, the actual work network, and they should be using their Wi-Fi. VPN, we wanted to make sure that's secure, and so 2FA needs to be enforced there, and role-based access control methods will be implemented. And then with our cloud services that HR uses, we also need to make sure that access control methods are installed there and that they're using 2FA and least privilege. Okay, some other considerations that we need to keep in account. First off, HIPAA compliance. Because we're dealing with a lot of medical data and health data, we have to make sure that we're HIPAA compliant. And so we need to make sure that all employees are doing their training, that access control methods are installed and followed, and also BAA agreements with third-party vendors. That ensures that third-party vendors are also doing HIPAA's best practices and they're HIPAA secure as well, so that our data doesn't release through them. For monthly audits, we want to make sure that those run every month so that we can ensure that the network is still safe. One of the things that I want to note is If there are new vulnerabilities that have been discovered, we need to make sure and take that into account and fix those if needed. For our operational lab, we talked about that earlier, but a couple other ways we're going to keep it extra secure is the BAA agreements, and we also wanted to do access control and training. Okay, the guest network. They're going to have a separate guest network and only have internet access, so they don't have access to any other resources. They also have to authenticate with a captive portal, which will help us monitor their activity so we can flag malicious behavior and kick them off the network if needed. And those are the main points of our security and network that we have designed for you. We hope you enjoyed it, and yeah.
Yeah, thanks so much.